No, you can ask questions while we're recording. And we're recording right now. So here's problem number 41. Find the equation of the line tangent the curve defined at this particular, by these parametric equations as that value of t. Let's remind ourselves of the formula that helps us find the slope of a parametric curve. And that is that dy dx is equal to dy dt divided by dx dt. You all agreed there? So what I'd like to do is I would like to find out what dy dx is. Or sorry, dy dt is. Dy dt is going to be the derivative of y with respect to t. That looks to me to be 2 cosine of t. So I will write 2 cosine of t right there. Let's find out what dx dt is, the derivative of x with respect to t. That looks to me like it's going to be negative 2 sine of t. So let's put that in there, negative 2 sine of t. Let's find out what is the value of dy dt, or not dy dt, stop that, dy dx, when the negative 2, when I take the derivative of cosine, the derivative of cosine is negative sine, all right? So what is the value of dy dt when t is equal to pi over 4? That looks to me like it's going to be 2 cosine of pi over 4 divided by negative 2 sine of pi over 4, which is going to be 2 times 2 root 2, or 2 over root 2, root 2 over 2, divided by negative 2 times root 2 over 2, and that looks to me like a big old negative 1. What does it look like to you? Yeah. All right. So, if we want to find the tangent line, we need a slope, mission accomplished, and we need a point. Now, the notation for finding the point looks something like this. I want to find out the value of x when t is pi over 4. That's the notation that we use to talk about plugging pi over 4 in for t. And that looks to me like it's going to be 2 times cosine of pi over 4, which is 2 times root 2 over 2, which is root 2. We also need to find out what is the value of y at pi over 4. Sine of pi over 4, 2 times root 2 over 2 again. That looks like root 2. So my point is root 2 comma root 2. My slope is negative 1. So in green, I write the tangent line. The tangent line is y is equal to my slope, x minus the x value, oops, plus the y value. And that's where I'm going to leave it. I don't care what they do about making it in any other form. That's where I like to leave it. Are we okay there? All right. And we want to do another one of these problems. So let me switch over to the next problem. Oh, I just didn't log out automatically. I'll live with that. All right, so now we have another parametric curve, and we want to find the equation of the tangent line. Same procedure. Let's find the slope first. dy dx is dy over dt divided by dx dt. Let me do some side work. What is dy dt? Bring the exponent down, leave the inside the same, and reduce the exponent by 1. Is that right? Maybe they would, the book would probably clean that up to 1 over 2 times the square root of t. Yeah, the microphone would have picked that up. dx dt looks like 1. Putting that together, I get 1 over 2 root t over 1, which is just 1 over 2 root t. Are we okay with that much? I tried really hard not to stand in front of the screen, by the way. Don't want to block anyone. All right, let's continue on. Well, so we found the general formula for slope. But what we want is, what is the value of the slope at that particular instance? What is the value of dy dx when t is equal to 1/4, which is 1 over 2 times the square root of 1/4. Keep on doing that. I keep on making 4s, but they look at 2s, and then I have to make them look at the 4. All right. What do we get when we clean that up? 1 over 2 times 1/2 is the square root of 1/4. So it looks like a big old 1. Great. So now we finally finished the slope portion of the program. Now we need the point. Brian, I was going to say that joke. All right. So what is the x value when t is 1/4? It looks like it's 1/4. What is the y value when t is 1/4? It looks like the square root of 1/4, which is 1/2. And then we'll switch over to the green marker for our final answer. That the tangent line is y equals slope times the quantity x minus x value plus the y value. And again, and that's where I stopped. Are we good there? Yeah. Oh, okay. Any questions more about that? All right, so let's finish.